Okay.
Hi, I'm Francoise von Trapp here for the BiTS workshop, and I'm with Simon McElrea of Invensas Corporation. Simon just completed his keynote speech on interconnectology, the road to 3D, and he's going to tell us a little bit about the key takeaways from that. Simon, can you share with some of the key takeaways from your talk this afternoon?
Well, the primary message of my talk was the theme of interconnectology. On the one hand, that is everything that's required to get silicon into systems, but it's also the interconnection of the people that are required to get silicon into systems. Today, technologies are not just lifted off a shelf. The product is designed with everything in mind, and that includes packaging and test.
And you talked a lot about the package-on-package model. How can we apply the package-on-package model to 3D ICs?
The package-on-package model is brilliant because it's a technical solution and it's a business model solution. So it enables companies that specialize in memory to work on creating a memory product and testing it, making sure it's good, and companies that work on logic, like let's say Qualcomm or Apple on SoC logic, to work on their product and then bring the two together with these pre-tested configurations. And that deals with all the issues of liability, of yield, and eventually product cost.
So in regards to the 3D ICs, are those parts going to be able to, are you talking about the overall business model, or are you talking about, how would that work? We talked a little bit about the business model, the vertically integrated, being able to handle the middle end technologies versus an open collaboration model. You called it a virtual
Supply chain?
the virtual supply
Right.
chain. Can you talk about that a little bit?
I think the reason I spend so much time talking about package on package was that we have to emulate that model to the best of our ability in 2.5 and 3D. 2.5 and 3D products clearly are technically better. They provide much greater bandwidth, much lower power, much smaller size. But if we don't deal with the issues of supply chain liability, the ability to test, determine yield, and for companies to work together in the model, it's just going to be problematic and time consuming to get to high volume. POP, package on package, solved that beautifully. So taking the elements from that and applying them to 2.5D, finding the right test points, the right known good points, is absolutely critical to making this work.
Okay, and there's also the issue of, you talked about packaging and 3D being really the value add, and that the newer companies are going to benefit from this value add, and the older companies are going to do continue doing the simpler technologies. So who pays? Who's going to be able to absorb the cost of CapEx? How are we going to be able to get these technologies? Is it going to be the foundry, the OSAT? You talked about different players who weren't really part of the equation before.
Well, the question of who pays for all of this really comes down to who needs it the most. Being in the heart of Silicon Valley, we've seen a revolution from companies like Apple and Google and Microsoft, Nokia, who are actually investing in semiconductor packaging, what we call interconnectology. They're doing it because they need to. Their devices are smaller and smaller, they're handheld, they're wearable. They can get the silicon. It's not difficult to get logic silicon, memory silicon, MEMS silicon. What is difficult is to integrate those into these wearable products, these handheld products. So if the supply chain doesn't come forward with all the investment that's needed, it wouldn't be too surprising, and it wouldn't be the first time that the investment came from that top level, the Apples, the Googles, the Samsungs.
Okay, and final question is with regard to this test and burn-in strategies group. What do they need to know about? What kind of data and specs can you share with them, so that they can develop the right tools for test and burn-in of the 2.5D and 3D package technologies?
Well, I'm delighted to be speaking at a test and burn-in conference, and I've actually spent quite a lot of my time talking at places that I would not normally be. If I spoke at packaging conferences, it's like preaching to the choir. So part of the mantra of interconnectology is to interconnect the people involved. In order to make 3D work, the number of test points, the metrology, and the ability to break this product up into testable units is absolutely essential. I think that the conversation needs to be continual between the test side, the socket side, and the packaging side, which it isn't currently. So I can list 25 things that need to happen, but probably 20 of those would be new to the test guys that don't hear it every day.
Okay.
Don't ask me what they are.
Okay. I don't know how to wrap this up. They will edit this out, hopefully. So do you have any final comments that you'd like to make? Just to...
As always, interconnectology is right at this most exciting point. To be in the heart of Silicon Valley, seeing these huge companies hiring packaging engineers, to see the challenges of these next generation wearable devices that require high density of silicon in a very small space. That's semiconductor packaging, that's interconnectology.
Thank you.
Thank you.